Have you ever wondered why protons and electrons don't just collide and create an explosion? Or why do different elements emit different colors of light? The answers lie in the groundbreaking work of Niels Bohr. Today, we'll explore the Bohr model of the atom and its implications. In the early 20th century, Niels Bohr proposed a revolutionary model of the atom. He suggested that electrons orbit the nucleus in specific energy levels. This concept explained why electrons don't lose energy and spiral into the nucleus. But why don't protons and electrons collide? According to Bohr's model, electrons maintain a stable distance from protons. They occupy discrete energy levels, which creates a quantum barrier. This prevents them from spiraling in. Now, let's discuss why different elements emit distinct colors of light. Each element has a unique set of energy levels. When electrons jump between these levels, they release energy as light. The color corresponds to the specific energy differences in that element. Shorter wavelengths, like blue or violet, correspond to higher energy transitions, while longer wavelengths, like red, correspond to lower energy transitions. Ever wondered why atoms emit light in specific colors? It all ties back to one groundbreaking model, the Bohr model of the atom. Let's recap what we just learned today. In this video, we had explore Bohr's postulates, how they revolutionized our understanding of atomic structure, and where the model falls short. Niels Bohr, in 1913, proposed a quantum model for the hydrogen atom. Here are the three key postulates of his model. Electrons revolve around the nucleus in specific, discrete orbits. These orbits correspond to fixed energy levels. While in these orbits, electrons do not radiate energy, a concept that broke away from classical physics. Electrons can jump between energy levels by absorbing or emitting photons. The energy of the photon equals the difference between the initial and final energy levels. The angular momentum of an electron is quantized. Bohr's model successfully explained the spectral lines of hydrogen, such as the Balmer series in the visible range. The quantization of energy levels, which accounted for why atoms emitted or absorbed light in discrete wavelengths. Despite its success, the Bohr model had significant limitations. It couldn't explain the spectra of atoms with more than one electron, such as helium or larger elements. The model ignored electron-electron repulsion and other quantum interactions in multi-electron systems. Electrons were treated purely as particles, which conflicted with later discoveries showing their wave-like behavior, as described in quantum mechanics. It couldn't account for the fine details in spectral lines, such as the splitting caused by relativistic effects or electron spin. In summary, Niels Bohr's model provides essential insight into atomic structure and light emission. However, it has limitations that later models sought to address. Now that you understand these concepts, explore more about atomic theories and their evolution.